Hey everybody, we're going to talk about similar right triangles. So this theorem applies for when we only have a large right triangle and the altitude, which goes from the highest right angle, which would be B, to the base. It makes three similar triangles. So the similar triangles here are triangle ABC, so the big one, is similar to triangle ABD, and it is similar to triangle DBC. So those three triangles. And I accidentally wrote these in the wrong order, I'm sorry. So it should be ADB and BDC, because remember when we write these, we have to always stay consistent and make sure that the letters are matching up. So like A, and B would be the same point for each of those, okay? So let's try this again. So identify the similar triangles in the diagram, then sketch them so they have the corresponding sides and angles in the same orientation, okay? So let's start with the large one. We have triangle PQR, okay? So if we have PQR, that means Q is the right angle, okay? So that's what's going to be important for all the other ones. So now we want to focus on this triangle here, okay? So if we look, S is now the right triangle. So when we write this, we want S to be in the middle. So now the only thing we need to do is determine what is going to be with P and R, okay? So if we look here, PQR, which was in the original one, the longest side was PQ. So we want to look for the longest side here, which is PS. So we're going to do PSQ. Should draw it a little bit smaller. Maybe this smaller. And the last one, we're going to do the small triangle, which is this blue one here. So again, S is going to be the middle letter because S is the right angle, okay? So what is the longest side? It's going to be QS. So Q and R. So it's going to be QS triangle. QSR. Okay? So if we remember back to the unit with similarity dealt with proportions. So we are going to write a proportion. Okay, so if we are going to find the value of X here, we want to look at the triangles, okay? So we have a large triangle and we have this small one here, okay? So if we look at the big triangle, 15 is our hypotenuse, and in the small triangle, 12 is our hypotenuse. So we're going to do the large triangle over the small triangle's hypotenuse, and then we would just look, okay, what is the large side here? It would be 9 over X. So we get 15x is equal to 108, and x is equal to 7.2. Okay, let's try it again. So if we look at the hypotenuses, so we have the small triangle and the large triangle. So do the large triangle and the small triangle. Okay, so then we have the large triangle is 11.2 and the small triangle is x. So we get 23.8, x is equal to 235.2. Divide that by 23.8 and you get x is equal to 9.9. And the last one, we have the hypotenuse, so do 25 over 24, then we have 7 over x. So 25x is equal to 168 divided by 25. X is equal to 6.7. Okay. The next thing we're going to talk about is geometric mean, which is geometric mean of two positive numbers a and b is the positive number x such that a over x is equal to x over b. So this is going to help us when we're trying to solve problems where x is going to be in a relationship of more than one similar triangle. So like saying that when we're trying to solve it, x is going to be a variable for two of the similar, okay? So how we do it, we do x squared is equal to ab, therefore x is equal to the square root of ab. So if we find the geometric mean, that means we're just doing, taking the square root of 6 times 30. So it would be 180, take the square root. It can be one of two ways. You can either do it that you take the square root of 180, or you just simplify it to be 6 root 5. I'm trying to look on here on my phone. Or 13.4. For this, we are going to do 16 times 28, which is 448. So we can get 21.2 or 8 root 7. 12 times 50. So we have 600. So we would do 24.5, or you can do 10 root 6. Okay. Oh, sorry. I lost where my next page is. There it is. So the geometric altitude theorem. So it says the length of the altitude is the geometric mean of the lengths of the two segments. So if we say BD squared is equal to AD times DC. So that means this altitude squared is equal to this leg, and this leg multiplied together, okay? So if we look at this for number 8, we're saying that x squared is equal to 8 times 12. So 8 times 12 is 96. Take the square root of 96, and we get, sorry, hold on. 9.8. Okay, so we have, we need to figure out what this other side is. So 37 minus 5 is 32. So x squared is equal to 5 times 32. So we get 12.6. Then we have 18 squared is equal to x times 15. So we're going to take 18 squared, which is 324 is equal to 15x. So then take 324 and divide it by x. So you get x is equal to 21.6. And then for this one, it's going to be x minus 30. Let's not do that. Let's say that this is y. We'll just give it another variable. So 21 squared is equal to 30 times y. So then we would have 441 is equal to 30y. We get y is equal to 14.7. And then we can just add 30 plus 14.7 is equal to 44.7. That's a lot easier. All right, so the geometric leg theorem says the length of a leg of a triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So this is a lot, but it's okay. So it says that AB squared is equal to AD times AC. So that's just saying if X is here, we're going to take and multiply AD times DC. Or BC squared is equal to DC times AC. But the difference here is that we're using the part closest and the whole length. So the part closest and the whole length. I like to think of this as like a sports game, okay? So if we have a sports game, right? Then let's just draw what I'm talking about. Let me draw better. So we have this large right triangle, and then we're split into two smaller ones, okay? So let's say we have A, B, and C. So in this case, we have defenders down here, A, B, and C, where AB is going to be this length, B is going to be this length, and C is the whole length here. So we kind of put this into like an attack situation where this person up here, X, has the ball, okay? So if X has the ball and travels down this side of the field, the two defenders that are going to attack are going to be this person and this person. So if in any kind of athletic situation, A and C are going to attack, okay? On the other hand, if X goes down this side of the field, B and C are going to attack. So then we're going to say, okay, X squared is equal to B times C. So thinking about it mathematically. Then if X is going to go down the middle of the field, we're saying X squared is equal to these two defenders, because those two defenders are going to attack. So if you think about it that way, it helps. So we have to find 24 plus 2 is 26. So X squared is equal to 24 times 26. So 24 times 26 is 624. So we get X is equal to 24.5. Then for here, we have to figure out what this part is. So 12 minus 7 is 5. So X squared is equal to 5 times 12. X squared is equal to 60. Take the square root of 60, and we get X is equal to 7.7. Now we have a couple problems. So we have X and Y, X, Y, and Z actually. So we just need to find the right path. So if we went down here, we would need to know what this value is, but we don't know it. And we don't know this one. So that's a 2 variable one. If we went to Z, we would need to know what this portion is, and X, 2 variables don't have it. So let's try 27. If we went down this leg, we would need this number and the whole number. Well, we only have 1 variable, so that's going to work. So 27 squared is equal to 24 times X. 729 is equal to 24X. X is equal to 30.4. Now that's going to help us because we can figure out what that other side is. So if we have 30.4 minus 24, that is 6.4 here. So now we can find y. Y squared is equal to 6.4 times 24.